Now that we've repaired our CI pipeline, we can further enhance it by adding static code analysis using a Python package named Bandit. We only need to include one new package in our requirements file. The Bandit package will provide us with basic static code analysis capabilities for our Python source code. It's really easy to use. We just say Bandit followed by the files we want to check. Let's check our database.py file first. Scrolling up, we see a timestamp indicating when the analysis started, followed by some results. This particular file has no security issues, so the output is kind of boring. The detailed breakout shows metrics indicating the number of issues by severity and by confidence. Severity is measuring how big of a risk something is. An SQL injection attack is a way bigger deal than forgetting to adjust a default timeout somewhere. Confidence is measuring how confident Bandit feels that this is a real issue. Sometimes issues are very obvious by looking at code, but in very complex projects, static code analysis may not be as confident with its assessment. Let's try our unit test file next. Scrolling up, we definitely have some issues now. The assert statement is considered a low severity issue because when Python code is compiled into PYC bytecode files, this statement isn't included, so it appears extraneous. However, it's highly relevant for test files. We can see that Bandit matches each violation independently, but since they are all the same, I'll scroll to the bottom. Before I do, note that this rule ID is B101. This time, there were 4 low-severity issues, all of which Bandit was highly confident about reporting. I think we should disable this specific rule. We can accomplish this using the --skip option and specifying the rules to skip. Now, we can see that there are no issues with our code. Next, let's try our Flask app, which is start.py. Scrolling up, we have more serious issues this time. The first issue is that Flask debugging is enabled. Bandit tells us this allows execution of arbitrary code, a huge vulnerability, and Bandit has medium confidence about it. Bandit is also reporting that Flask is listening on all IP addresses, which means the service could be publicly accessible. However, both of these issues aren't important for our specific use case since we are in an educational environment. We could easily turn off these usability features to secure the app, but it will just make learning harder. We could manually skip these rules, but we can use another technique known as the nosec comment. Let's see how that works by opening the start.py file. At the end of the line containing the issues, we can just add a comment that says nosec, which tells Bandit to ignore the entire line. Let's save this file and rerun Bandit to ensure we don't have any other problems. Remember, we don't need to skip these rules because our source code now instructs Bandit to ignore that line. I suggest we add Bandit to our quick script so that it becomes part of our overall regression test and ultimately our CI pipeline. Like Pylint, we can grab all the Python files at once, and being sure to skip the B101 rule related to assert statements, we can analyze the entire project. Let's run the quick script to ensure everything still works. Okay, we see our system tests have passed, which means the app functions, but let's scroll up and check on the Bandit output. This looks great. Bandit didn't find any issues during its analysis of our codebase. You want to be conservative about skipping rules and applying the nosec comment in your code since you could be masking real security issues. Use these techniques sparingly.